Yes, in this video, I'm going to discuss about the nucleophiles here. In my previous video, I've already discussed about the free radicals and the electrophiles. In my previous video, you can definitely go back and check with them. Now, I'm going to discuss about the nucleophiles here. Yes. So what are nucleophiles here? Again, files means seeking here. As the name suggests, nucleophiles means they are in search of the nucleus, which means that they are electron-rich compounds. So they go in search of the positively charged centers. So they react with the positively charged centers as they are electron-rich, and nucleophiles means nucleus seeking. They go in search of the nucleus. So they can easily donate the electrons to other substances, and it's represented by Nu minus or Nu. So the easiest way to remember what are nucleophiles means the minus. When you remember this Nu minus, which means this Nu, nucleus, go in search of the nucleus, and minus means they're electron rich. So go in search of the nucleus, reacts with the positively charged centers. And the examples for these nucleophiles are, as it is electron rich, so we can definitely assume that the negatively charged ions will all come under this category, like Cl minus, Br minus, and so on. And R minus, which is nothing but an alkyl group, is called as carbanions. Okay, this is very important, and let's remember this word. And the second category, which comes under the second category of examples, which comes under the nucleophiles, are neutral molecules like water, ammonia, RNH2, and so on, where the central atom is octet complete here. Unlike the electrophiles, here the nucleophiles are octet complete. If you count the number of electrons around this oxygen atom, which is a central atom in water molecule, 1, 2, 3, 4, 5, 6, 7 atom. This covalent bond has 2 electrons. So total number of electrons are 8. So it's octet complete. So it can easily donate the electrons now because it has 2 lone pairs around this oxygen atom. So they can easily donate the electrons. So which makes it a nucleophile. So what are the two categories of examples under the nucleophiles? Is one is negatively charged ions, that are anions, and the other one is neutral molecules like water, ammonia, in which the central atom is octet complete. So yeah, let's discuss the second example, like ammonia, where again the nitrogen here as again having the lone pair. See, it has lone pair and octet complete. When you count the number of electrons around this nitrogen, we have 1, 2, 3, 4, 5, 6, and 7, 8. So octet complete with the lone pair on the central atom. So ready to donate the electrons, which is making it a nucleophile. Yes, and one more thing, what are Lewis spaces? They are electron pair donors, so they can readily give away the electrons. So the nucleophiles are also the electron pair donors. They can give away the electrons. So all nucleophiles are Lewis spaces. So yes, let's now see the differences just to have an idea of just to know the differences here. I've just prepared the slide for you. Just at the glance of it, you will know what comes under what, like what are the differences in between these three. See, what are free radicals? They have an unpaired electron, they're positively charged, they're negatively charged. What are these called? These are called free radicals, these are called as cations, these are called as anions. And these are produced by homolytic fission. These two are produced by heterolytic fission. and these are represented by E or E plus. This is represented by Nu or Nu minus. The examples for these are free radicals like Cl free radical, H free radical, R free radical. And the examples for electrophiles are all cations like H3O plus, R plus, and so on. And for the nucleophiles, it is all negatively charged species like Cl minus, Br minus, R minus, and yes. When you come to the second category of examples like neutral species, like NO or NO2 with a single electron, neutral molecules like BF3, AlCl3, where the central atom like B or Al are octet incomplete, comes under electrophiles. So they are ready to accept the electrons because they are positively charged, or they are octet incomplete. And the nucleophiles, the neutral molecules, examples like water and ammonia, where the central atom has lone pair of electrons here, ready to donate the electrons because they're octet incomplete and having lone pair of electrons on the central atom. And all electrophiles are Lewis acids and all nucleophiles are Lewis bases. Just a glance of this just at a glance of these differences, you will know what are the differences between these three categories. Yes.